we're going to just review some of these factoring complex in the complex form. If you look at number 29, ax squared plus bx plus c, we're just going to use the quadratic formula. So x is going to be equal to minus b, negative 2, plus or minus square root b squared, which is 4, minus 4a, which is 10, or 3 times c, 10. So it'll be times 30. All over 2 times 3. So x is going to be equal to negative 2 over 6, or negative 1/3, plus or minus square root, what's that going to be? I can take out a 4, so that's going to be 4 times 1 minus 30. What's 1 minus 30? 29, right? So this is going to be negative 1/3 plus or minus square root of 4 is 2, and square root of negative 29. Uh-oh. What are we going to have to do with that? Put an I there, right? So x is going to be equal to negative 1/3 plus or minus square root of 29 over 3i. How's that? On good. Now this is what I want to help you with today. These are the two. Well, now help me out. All right. So we're going to take these roots and put them into factors. So here's how this works. We have 2 roots equal to negative 1/3 plus square root of 29 over 3i, and you have negative 1/3. Notice both of these are negative 1/3 minus square root of 29 over 3i. Okay? These are still roots, or roots. These are the roots. If you want them into factors, which you're going to want tomorrow, then what you do is you go x minus a negative 1/3 minus root of 29 over 3i equals 0. And then this one, x minus a negative 1/3 minus a negative square root of 29 over 3i. These are factors. And I think they wanted factors, didn't they? Completely factor, it said. So there you got it. Those are what those answers should be. Did we do both 31 and 33? Or did we do one? We did 33. Do you want to see 31? Let's do 31. And so next, let's take number 31. And 31, we're going to be given a hint. That means that x equal negative 5. X equal negative 5 is a what? Factor or root? So yeah, it's a root. Okay, so then what you're going to do is you're going to try to factor this out of here. So the way I like to do it is to do something called synthetic division, taking the coefficients 1, 6, 6, 5. 1x to the third, 6x to the second, 6x to the first, 5x to the 0. And since these are all coefficients, I'm going to put the root right there. Now, we drop the 1, multiply by negative 5, add these up, multiply by negative 5, add these up, multiply by negative 5, and lo and behold, we get 0. When that happens, you know that it factored out, that it's actually a root. This is x to the 0, x to the 1, x to the 2. So now we have x minus negative 5 as a factor, 1x squared plus 1x plus 1. Right? Have we factored this all the way down? Not yet. So we need to keep going. This is a, b, and c. Okay? So we're going to use quadratic formula, figure out what that is. Coefficient formula of x is b is 1, so we go the opposite of 1 plus or minus square root negative 1 squared minus 4 times 1 all over 2 times 1. 2a. So this is going to be negative 1/2 plus or minus. 1 minus 4 is negative 3, so we'd say the square root of 3i over 2. Now, whenever you see 1/2 and square root of 3 over 2's, what does that make you think of? Unit circle. So these are points on the unit circle for sure. The two roots that you have will be x equal to negative 1/2 plus square root of 3 over 2i. The other one is still a negative 1/2, but it's minus square root of 3 over 2i. So when we write these as factors, we go x plus 5, then we go x, move everything to one side, minus a negative 1/2, minus square root of 3 over 2i, times x minus a negative 1/2, minus a negative square root of 3 over 2i. And that is an ugly but factored out, totally factored out polynomial. You feel good about these? Maybe? No. So that brings us to 47. A little different, but not that bad. Go to 47, you see x is equal to I as a hint. Now that's not a hint. What is that, by the way? X equal to I. Root or factor? Turn to your neighbor, tell him what it is. It's a root, isn't it? But this is a really good hint because due to the quadratic formula, these complex numbers always come in pairs. What's the other one? Negative I, you're right. Okay, so write that down. These are the two roots. Roots. Now make them into factors. So to make them into factors, you're going to have x minus I equals 0. There's a factor. And then x minus a negative I is your other factor. These are not real factors. We're going to turn it into a real factor. So 1 without i's. Watch what happens when I multiply x times x is x squared plus xi. And then I take these two, negative ix or xi minus I squared. Now what was I squared again? Negative 1, yep. Okay, so what's the opposite of negative 1? 1. So these two cancel out, and you're going to get x squared minus a negative 1. That is the real root. The real factor, I should say. Oh, we're not done. I wish we could say we're done. We're not even close to being done. So now what we're going to do is we need to take this thing out of here. So we have x to the 4th minus 2x cubed plus 27x squared minus 2x plus 26. And I want to take out of there, I want to take x squared plus 1 out of there. Now I showed you synthetic before, and people say, well, why didn't you do synthetic here? It'd be a lot easier. Really? Take a look at this. Don't do this. 1, negative 2, 27, negative 2, 26. And then 1, negative 2, 27, negative 2, 26, and then we do this synthetic, and we have I as the root. So you drop the 1. 1 times I is I. Add these, negative 2 plus I. Is that going to be very helpful? That gets nasty in a hurry. Don't do synthetic with that. Doesn't work. So what we did is we got a real factor, and now we're going to factor this out of here. And you're going to get a chance to do this in a little bit, but I'm going to do this one with you. X squared times what is x to the fourth? X to the second, right? And so x to the second is, times x squared is x to the fourth. X squared times 1 is x squared. Draw a line under there, and then we're going to reduce this like so. And then you're going to get 0, and then you're going to get 27 minus 1 is 26x squared. Is that 26x squared? Does that look bad? That might come in handy later. Yeah. So then this is going to drop down and give you negative 2x cubed. Drop this one down, negative 2x. If you want to, you can drop the 26. And now we go to the next one. All right, so next, you're going to, x squared times what is negative 2x cubed? Negative 2x, yeah, because negative 2x times x squared is negative 2x cubed. And then don't forget to go negative 2x times 1. Oh! Is that good? Does that make you happy? Makes me happy, because then when I do the opposite thing, now this becomes 0. This becomes 0. When I drop down the 26x squared and the 26. And these are just 0 and 0. Well, what x squared times what is 26x squared? 26. Oh, excuse me. Yeah, no, that's right. 26. 26. And so this will be 26x squared plus 26. Don't forget that minus sign again. And that will give you 0. So, what we did is we found that when you took that x squared plus 1 out of there, you get x squared minus 2x plus 26. Now what you need to do is to find the roots. So x will be minus b, which is minus negative 2, plus or minus square root of b squared, minus 4 times 26, times 1, all over 2 times 1. So that's going to be 2 over 2 plus or minus 4 minus 104. What's 4 minus 104? Anybody know? Over 2. Yeah, it's the square root of 100. So you're going to get 1 plus or minus square root of 100. Negative is 10i over 2. That's just 1 plus or minus 5i. Those are my two roots. So, now, we have roots. You have these two roots, x equal to I, x equal to negative I, you have x equal to, sorry about that, 1 plus 5i, and 1 minus 5i. So all you have to do now is write this out as a factored form. X minus I times x plus I times, careful, x minus 1 minus 5i times x minus 1 plus 5i. Those are the 4 factors. And will we have more than 4? Nope. That's the 4. So that's how to factor out of a polynomial down to the complex roots and factors.